Greetings today. My presentation will be on the Marine Corps Infantry. This is also my future MOS, Military Occupational Specialty, but I will be a machine gunner from what I am told right now. Today I'm going to show you the type of mathematics used to successfully hit our targets and things as such. Here's a little video on what we do. It'll be coming in a couple seconds actually. Thank you. Most people don't know this, but when a round is fired, it actually doesn't go straight. And I apologize for this photo here. It's not really in full image, but bullet, once fired, it actually curves. That's what most people don't know. And here are a couple examples of the math used. I tried to copy this exact formula here, or format, but I don't think I succeeded in that. It's a bit confusing, but I'm pretty sure with the proper instruction I'll get it down. Good evening, viewers and Dr. Cowan. Today I'm going to give a model on the one of the types of math used in the military. Kind of worked it out already for you. Okay, so check it out. So in the military, they might use type of geometry or trigonometry to effectively hit our target. Example, if I'm like for example, a sniper at on a mountaintop, as this guy is here. Here's a sniper, here's a spotter. Target is this guy here, unfortunately. So say we're about 400 feet out from the person, from the target, and we're a bit higher than him, of course. You see that slope here. What snipers usually do, they use landmarks or basically what they know to get their calculation. So we use this tree, the 38 feet high, I don't know, tree as like a reference, and the guy is about 6 foot. So we just subtract that 38 minus 6, we get 32. So this angle here, well, the head from the guy's head from the top of from the base of the I guess the tree stems or something like that is 32 feet right here. So we can draw a triangle here, and all we're missing right now is the degree. And to find a degree, we have to use the tangent -1. Continuing on. So we put in tangent -1. I forgot my calculator in class. And then we put 32 into parentheses divided by 400, and we got 4.6. And yeah, we put 4.6. And if we were to put that into like the sniping calculator, it's a scope. We do like 1 click up for a degree, 1 click to the side for windage, like there's a 3 mile per hour wind. We shoot it, fire the weapon, and as you know, a bullet doesn't really go straight. Like, you see this line here, that's eye level. A bullet will just travel down like this as it decelerates. So yeah, that's the type of math used. Here's another one. I can't really explain it. It's really complicated. I think I'll do something on the back too. Yeah. I'll show the back first. I'll try to explain it to the best of my ability. This is just again my explanation of how a bullet does not travel straight. It actually goes down. So here's a target, eye levels, dots right on that are horizontal, and here's the scope. We have to go 6 degrees up to effectively hit the target and the bullseye. So shoot it. Again, the bullet does not go straight, doesn't go like that, it curves. Here's a little if I can zoom in. Givens, I forgot what the zeros mean. I wrote it on the back. The initial velocity of, I use a Remington 700 for, that's a not a Remington, that M24. That's one of the snipers using the Marine Corps. Sniper rifles using the Marine Corps. And I have to write a couple of facts down just to get the math down. Because I used a 7.62 millimeter NATO round. The average exit speed of the round is 457.2 meters per second. So, well, there was a correction there. Initial velocity, VO, is 790. The time to hit the target is 6 seconds. I think I had to, like, when I was reading it, I had to divide it or multiply one of those and get this to get the range of the target, which was 1,371.6. And on the back here, I just have some formulas that I forgot to write down on the side here. Oh, here it is. Formula for distance is x vxt. I wrote the definitions down here. Vx is the velocity along the x-axis. Vxo is the initial velocity along the, I can't read my own hand. Vy is the velocity along the y-axis, vertical. Vyo is the initial velocity along the y-axis again. G is the acceleration, and T is the time taken. So here are the formulas defined. To find, you know what you need to know. Well, yeah, to find your for distance, velocity, distance again, and your vertical velocity. That's all I have about for the math. I'll probably record another session soon. Thank you.
Hello. Okay, today I'm going to cover the simplest math there is. I think it's math because it has numbers in it, and mathematics has numbers. So we're going to go cover the degrees and the miles it takes to get from point A to point B. Okay, so we are at a mission. We just completed a mission here at a village called Zema. Zema is right here. And now we need to get back to Bagram Air Force Base. It's right here. Okay. Keep in mind, this is Afghanistan. This is a hostile area. We just can't go directly. We're not supposed to take the same route. We're not supposed to take the same route as we did coming. So what we do is in the military, we make vertical lines. So let me do this here. Okay, vertical line. I hope that's vertical. Like this. Make a couple slashes, so you can make slashes. Then you go to your next point, make another vertical line. Uh-oh. There we go. Okay. Now let's make these dots a bit bigger, because I will lose them if I don't pay attention. Okay, next we're going to find out the the angle. Excuse me for the noise. My colleague Sheldon is here. We all know Sheldon. Okay, as you can see, these are actually interior angles, I believe, from geometry. One of you guys can, correct me on that if I am wrong. Okay. Let me just double check. Alright. So, from Zema to Bagram Air Force Base will take us at a degree. Oh, wait, I did this wrong. My apologies. Like this. Okay, so since this is north here, this is going to be north. I've got to put the protractor to 0, pointing north. So the degree is just about 18 degrees north. 18 degrees. Okay, so we already have our degrees here. Now we got to find the miles. This is, keep in mind, obviously this is not drawn to scale. So we're going to pretend that we're 0. Oh, it's right here. Pretend that 0 here is in 1,000 kilometers, because the military uses kilos instead of meters or miles. So if you hear me say like 1 click, that's 1,000 kilometers. So I already passed 1 click. 1 click is really far, so this is probably up to scale. So it's 1 click, and we're just about 1,500 right here. So okay, 1,500K. That's like a marathon right there, isn't it? And yeah, that's about it. Hopefully. So to get from Zema here, to Bagram, we're at a degree at 18 degrees with the compass, and the distance covered will be 1,500 kilometers. That's about it that I have for you. Now we can do something else, but I forgot how to do that math. It's where we create a triangle like this, create 2 points, and we find, we have to find like one of these here, but I forgot how to do that, so we're out of luck. But yeah, that's about it. Plotting points on the map, finding the distance and the degrees of which you have to get to your destination. That'd be it. Thank you.